So welcome. This is Atomic Physics from IBDP, past paper questions, physics, HL and SL combined. So for some of the few past paper questions of MCQ based on the topic atomic physics. The first question, photons of energy 2.3 electron volts are incident on a low pressure vapor. The energy levels of the atom are shown. What energy transition will occur when the photon is absorbed by the vapor. So we have to check that which transition or which difference between which two levels is 2.3. So I can clearly see that when I take delta E equals to negative 1.6 minus of minus 3.9. This gives me nothing but what? 2.3 electron volts. So only the option A is going to be the correct answer. Coming to question number 2, a nucleus of phosphorus decays into silicon with the emission of particle X and Y. So we try to balance this equation. So we want 15. So over here 14. So this should be plus 1 and this should be 0 because 30 is 0 and this should be 0 and 0. So when I say it is positive, so therefore it has to be nothing but what? It should be a positron. So where is positron over here? Either option A or option B. But do remember that positron is always associated with a neutrino. So therefore option D is correct and option A is not correct. Whereas electron is associated with antineutrino. So you have to see carefully, a positron will be always coming with a package of neutrino. So therefore option D is going to be the correct option. Question number 3. Atomic spectra are caused when certain particle makes transition between energy levels. What is this particle? So only energy levels means always electrons are the one which is transiting between the what is this energy levels. Therefore the option is electron, whereas proton and neutrons are the nucleons. They are not what is this coming outside of the nucleus, and alpha particle is a helium nucleus, so it is not associated with any kind of what is this transition between the energy levels. So therefore the only option is option A, electron. Next, question number 4. The half-life of a radioactive element is 5 days. A freshly prepared sample contains 128 grams of this one. After how many days? 16 grams of this element is left over. Instead of using the formula directly, I am using 128 becomes 64, 64 becomes 32, 32 becomes 16. So after one half-life, second half-life and third half-life. So which is that option? Option C is going to be the answer. Question number 5. Which statement about atomic spectra is not true? We know that atomic spectra is discrete energy levels in atoms. So this is correct statement. And atomic spectra can be either be emission or absorption. That is also correct. And absorption is because of gain of energy and emission is because of loss of energy. So this is also correct. And only we are left over with fourth option. Emission lines always correspond to visible part of the electromagnetic spectrum. No, it can be for the invisible part also. So therefore option D is going to be the correct option for that, which is not true for the atomic spectra. Coming to question number 6, two pure samples of radioactive nucleus X and Y have simple same initial number of atoms. The half-life of X is T half. After 4 half-lives, the ratio of the number of atoms is 1:8. What is the half-life of Y? So first of all, I'll take sample X. What is happening to sample X? How many half-lives have been passed? 4 half-lives have been passed. So 0.5 whole to the power of 4, which is 0.0625. This 0.0625 of the original sample atoms will be left over. This will be remaining. Now for sample Y. Sample Y. What is it happening? The ratio of sample Y is 8 times of the X. When I do the cross multiplication, it is nothing but what? 8 times more than X. Means it will be 0.0625 times 8, which is nothing but what? 0.5 of original sample atoms. 0.5 of original sample atoms means nothing but what? It is one half-life has been passed. So it means nothing but what? After 4 half-lives of X equals to 1 half-life of Y. 1 half-life of Y. So therefore, what am I going to do that? Option D is going to be the answer. 4 half-lives of X is going to be the 1 half-life of Y. So that is the answer for question number 6. Question number 7. The energy level diagram for an atom that has 4 energy states are given: 1, 2, 3, 4. Now, what is the number of different wavelengths in the emission spectrum? So when is emission spectrum is happening? Whenever there is an electron transition between two energy levels. So out of 4, I have to choose 2, 4C2. 4C2 is going to be 6. So the option is going to be 6. You can literally draw rather than drawing. This is the best way. 4C2 is going to be the answer. Now, coming to question number 8. A detector placed close to a radioactive source detects the activity of 260 becquerel. So how many becquerel is that? It is 260 becquerel. Now, that's the most important thing. The average background one is nothing but what? 20 becquerel. So 260 minus 20. So basically, activity of the sample will be 240 becquerel. So this will be activity of sample. That's going to be the basic activity of the sample. Now, the radioactive element has a half-life of 9 hours. And how many hours it is there? 36 hours. So therefore, number of half-lives. Number of half-lives. Number of half-lives will be 36 divided by 9, which is 4 half-lives have been passed. So now it is 240 becquerel and it is 4 half-lives have been passed. So therefore, 240 divided by 2 per 4 half-life, 2 per 4. So it is going to be nothing but what? 15 becquerel. But again, don't worry, that's not the answer. In a hurry, you may be writing that is as the answer, but I want the total activity because again, we have to add back the background one. So 15 plus 20, which is going to be nothing but what? 35 becquerel. That's going to be the answer. So answer is option D. Question number 9. Element X decays through a series of alpha and beta particles. Which series of emission results an isotope of X? So we have to form it out. An isotope of X. When does an isotope of X is being formed? What is the definition of an isotope? Isotope. So first of all, isotope, what will happen? Number of protons will remain same. Number of protons remains constant. But alpha particle, what will happen? It is minus 2 protons. Whereas beta particle is nothing but what? Plus 1 proton. So if I write over here, if I have an element A X with X over here and A, now if one alpha particle is given out and Y is formed, it becomes A minus 4 and X minus 2. One beta particle is formed, is given out, then A minus 4 remains same, X minus 2 becomes X minus 1. It gets added up 1. Now again, Z becomes X because X minus 1 becomes X if at all another beta particle is given out. A minus 4. So one alpha particle, one beta, and another beta particle. So therefore, one alpha and two beta gives you the option. So option A is going to be the answer for question number 9. Question number 10. So what does this question number 10? It is from 2018, November, TZ0, question number 24. So it says the graph shows a variation with time activity of a pure sample of a radioactive nuclide. What percentage of nuclide remains after 200 seconds? He is asking us to after 200 seconds. So therefore, we can see that 2.8. 2.8 is the starting one. Now it becoming half. 2.8 divided by 2, which is nothing but what? 1.4. So 1.4. So we are seeing it at 1.4. Now what can I say is 2.8 becquerel is becomes 1.4 becquerel. And how much time is there? You can see that 1.4 becquerel is, when we see, it's 50 seconds. It's how much time it is taking it out? It is 50 seconds. So that is my half-life. Half-life is 50 seconds. So now 200 seconds. 200 seconds divided by 50. So how many half-lives are there? 4 half-lives are there. So if I consider 0% or 0 half-life, it is 100%. 1 half-life will be 50%. 2 half-lives will be 25%. 3 half-lives will be 12.5%, and 4 half-lives will be 6.25%, which is approximately equals to 6.3%. So where is the option? Option B is going to be the answer. Question number 11. This question number 11 is from 2019, paper 1 of SL. Question number 28. So what is it telling? Which of the following atomic energy level transition correspond to photons of shortest wavelength? So he's asking about shortest wavelength. Shortest wavelength means nothing but what? We know the formula is nothing but what? E equals to hc upon lambda. So if energy is highest, wavelength should be smallest. When will be the energy will be the highest? So whenever there is large difference between the energy levels. Where is the large difference between the energy levels? So for that, what am I going to do that? A and C. You can see that C is the biggest one. Among all, C is having the wider energy gap among A, B and C and D. So C is going to be having the biggest energy level. So high is the energy level, the wavelength is going to be low because they are inversely proportional to each other. In A, B and C and D, we can see that C is having the highest difference of the energy level. So question number 12, a radioactive nuclide with atomic number Z undergoes a beta decay. Beta decay means whenever there is a beta decay, what is happening is atomic number is decreased by 1. So answer has to be either A or B. Now we know that beta decay is always associated with nothing but what? A neutrino. So therefore option A is going to be the correct answer. So you need to memorize a beta decay is associated with a neutrino. Now coming to the next question. Question number 13. What is he saying? The energy levels for an atom are shown to the scale. Next, what is that? The photon of wavelength lambda is emitted because of the transition between E3 and E2. It is a transition between E3 and E2. Which transition leads to the emission of photon of longer wavelength? So we want a longer wavelength. Longer wavelength means nothing but what? Energy has to be the smallest one, because we know that energy equals to hc upon lambda. Hc upon lambda. As longer wavelength means nothing but what? The energy has to be smallest because they are inversely proportional to each other. So which one is having the smallest one? We can see that E2 to E4, this gap is the smallest one among all. So therefore, which option is that? Option B is going to be the answer. Question number 14. A proton, an electron and an alpha particle are at rest. Which particle has the smallest magnitude of ratio of charge to mass of each particle? Which particle has the largest magnitude of ratio to charge mass? So ratio to charge mass, smallest and largest one, we are supposed to find it out. So what are we talking about? We are talking about over here proton. Let me make a table over here. We are talking about proton, alpha particle and an electron. So charge for proton is E, for alpha particle is 2e, and an electron is also E. Whereas mass is U and 4u, and it is U upon 2000. Now when I find it out the ratio, it's going to be E upon U. Over here it will be 1 upon 2 E upon U, and over here it will be 2000 times E upon U. So which one is the largest one? Now we can see that electron is the largest one. And which one is the smallest one? The smallest one is going to be nothing but what? The alpha particle. So smallest is alpha and the largest is electron. Now coming to question number 15. X is a radioactive nuclide that decays to a stable nuclide. The activity of X falls to 1/16th of the original value after 32 seconds. What is the half-life of X? So I'm supposed to find it out, half-life of X. So for that, what am I going to do it out? I'm going to use that formula. So 1 half-life becomes half, 2 half-lives becomes 1 upon 4, 3 half-lives becomes 1 upon 8, and 4 half-lives becomes 1 upon 16. So therefore, it is 4 half-lives in 1 upon 16. So what am I going to do that? It also says that original value is 32. So 4 half-lives equals to 32. So 32 equals to, or 1 half-life equals to 32 upon 4, which is 8 seconds. Because in 1 half-life it becomes half, 2 half-lives it becomes 1/4, 3 half-lives it becomes 1/8, 4 half-lives it becomes 1/16. So it has done 4 half-lives in 32 seconds. So 1 half-life will be equal to 8 seconds. So which is going to be that option? Option C is going to be answer. Now question number 16. So which graph shows the variation of the activity? What is he asking it out? Which activity he is asking? Activity A with time t for a radioactive nuclide. So what are we supposed to do that one for this? So we are going to read the graph for this one. Half-life. What does half-life shows? Half-life shows the activity changes with time, and it is nothing but what we need know that it is exponential decay curve. So all are exponential decay curve, and it will not reach x-axis. It will not reach x-axis. So therefore, which is reaching x-axis? Option A is reaching x-axis. Option C is reaching x-axis. So answer has to be either A or B, and it should be option begins. It should begin when t equals to 0. So it is not becoming when t equals to 0. At t equal to 0, it is beginning. So therefore, option D is going to be the correct answer. So if at all we consider these three conditions, exponential decay and will not reach x-axis and begins when t equals to 0. So there, because the formula is A times A equals to A naught times e to the power of minus lambda t. So which option is the correct option? The option D is going to be the correct option. Question number 17. Which statement about alpha particles is about alpha particles, beta particles, and gamma radiation is true? We have to find it out which statement is true. So for that, what am I going to do that? Read the question carefully, because 4 options are there. We have to be very much careful in reading the options. Sometimes the options may be misleading. So we will read the options very carefully over there. The first option. Gamma radiation always travels faster than the beta in vacuum. Yes, gamma are light and beta has some, at least some weight. So therefore, though mass is negligible, but it has still weight. So therefore, gamma will always travel faster. In air, beta particles produce more ions per unit length travel than the alpha particles. No, because alpha are more ionizing. Alpha particles are always emitted when beta particles are emitted. No, it is not compulsory. They are independent of each other. Alpha particles are deflected in the same direction of beta. No, alpha is positive, beta is negative. So therefore, they cannot be deflected in the same direction. So therefore, option A is going to be the correct answer. Question number 18. 4 of the energy states for an atom are shown. Transition between two states is possible. Shortest wavelength. We know that energy equals to Hc upon lambda. Hc upon lambda. Shortest wavelength means nothing but what? Energy has to be the maximum. Where is the maximum difference? Maximum difference is between E4 and E1. Is the maximum difference. Do I have E4 and E1? Yes. Option what is this? A is going to be the having the maximum difference E4 and E1, whereas E4 and E3 is the smallest one. So therefore, what is this? Lambda can be low if there is a maximum energy change. So this is a high, the difference is high, then lambda will be low over here. So That's the answer. Question number 19. A simple model of an atom has three energy levels. The difference between the adjacent energy levels are shown. What is he asking us to find it out? He is asking us to find it out what are the two smallest frequencies in the emission spectrum. So we will be again using the same formula. What is that formula? We'll be using it out. Frequency equals to delta E upon H. So for F1, it is 6.63 times 10 power negative 19 joules upon 6.63 times 10 to the power of negative 34 joules second. So it's going to be 1.0 times 10 to the power of 15 hertz. Whereas for the second one, it is 13.3 times 10 power negative 19 joules divided by 6.63 times 10 to the power of minus 34 joules second. So it's going to be nothing but how much? 2.0 times 10 to the power of 15 hertz. So the option is going to be nothing but what? Option C. Question number 20. Three particles are produced when a nucleus of magnesium undergoes beta plus decay. What are the three particles? So magnesium is undergoing beta plus decay. So he is asking beta plus decay, not beta minus decay. So beta plus decay is being undergoing it out. What are the two particles he is asking us to find it out? So let us write it out over here. 23 magnesium 12. 23 magnesium 12, it is undergoing carefully because small mistakes may arise it out and it will be landing up into the different answers. So we have over here sodium, obviously sodium 11. Whenever beta plus particle is being decayed, the atomic number decreases by 1. So sodium is nothing but how much? 23. So in order to balance it out, 1 beta 0 and again nothing but what? A neutrino is there, 0 0. So therefore which is that option? Option A is going to be the answer. Question number 21. He is asking us to, when high energy alpha particle collides with beryllium nucleus, a nucleus of carbon may be produced. What are the products of this reaction? So we have to find it out, the products of this reaction. So what is that? Let's write over here 2He4 plus beryllium 4 9 gives rise to, obviously it is carbon, we don't know that one, and NX, a blank over here, a blank over here. So we know that 4 plus 9. So law of conservation of energy, is it happening over here? 2 electrons and 4 electrons will give you nothing but what? 6 electrons plus 0. So this number has to be nothing but what? Compulsorily the 0. Now conservation of nucleon number. Conservation of nucleon number is nothing but what? 4 plus 9 should be equals to, because it is an isotope of carbon, 4 plus 9 is 13. So obviously only it has to be nothing but what? 12. 12 plus nothing but how much over here? 1. So 12 plus 1 is 13. So which is the correct option? Carbon 12 and a neutron. Therefore option B is going to be the answer. Coming to question number 22, the diagram shows 4 energy levels for an atom of a gas. The diagram is drawn to scale. The wavelengths of the photons emitted by the energy transition between the levels are shown. What are the wavelengths of spectral lines emitted by the gas in the order of the decreasing frequency? We want decreasing frequency. So therefore, the frequency, again, we know that energy equals to Hc upon lambda. So what is happening over here? So from here, energy equals to Hf. So if the frequency is decreasing, energy is also decreasing. So we have to see that which is having the least energy. Least energy means nothing but what? Least energy, we can see that lambda 3 is having the least energy because that is the least difference. So which option is the least energy decreasing? So least one, lambda 3 is over here, either option B or option D. So option A and C are relegated. So lambda 3. Then the highest one. Highest one is nothing but what? Lambda 4 is going to be the highest one. You can clearly see that this is a maximum one. So lambda 4 should be the highest one. Where is the lambda 4? Option B also has lambda 4 and the lambda 4. Now the next highest one will be nothing but what? Lambda 1. The gap is going to be lambda 1. And finally it is lambda 2 and lambda 3. So which option is that? Option B is going to be the answer. So because we know the formula, energy equals to hf. If the frequency decreases, energy also decreases. So energy is highest for lambda 4, next highest is for lambda 1, and the next highest is for lambda 2, and least for lambda 3. And the last question number 23. Some transitions between the energy states of a particular atom are shown. Energy transmission E3 gives the rise to a photon of green light. Which transition will give the photon of larger wavelength? He's asking which one is giving a larger wavelength over here. Again, we know the formula energy equals to hc upon lambda. Larger wavelength. Wavelength is larger means energy has to be the smallest one. Which one is having the smallest energy among all? So by visualization, we can see that the energy is smallest over there for E4. So therefore, option C is going to be the answer. So that completes past paper questions till 2022 from 2016 onwards based on the topic of 7.1 atomic physics. See you in the next video. Bye.